Okay, let's start looking at this. You feel like you got pretty far on it? You feel like you did okay?
No, that's why we need you.
Oh, no. Okay, well, the first thing we want to do is we want to look at this and separate it into two different free body diagrams. The first one, we're going to work with just the light. Why is my Apple Pencil not working? Well, maybe we'll have class today. No, it's not true.
To invest in ship, right thing.
You got games on your phone?
Interesting.
I don't want to try writing.
No.
I'm working now. Yeah, we are. Okay.
Damn it.
Wow. So that's going to be on YouTube.
I'm the Zoom recording.
I never got into it, so I don't know.
Glad you just
Really enjoy it. It's just next generation.
Every physics student in the country is going to go, I feel that.
And Mark, you know, you can auto correct triangles, right? You draw a triangle and hold it up to a circle. Or draw a
I know,
square.
but
It does that with the square too. Yeah, just like,
Now
and then
hold
you,
it.
and then resize it.
Oh, look at that.
You can resize.
No. Week one, she said.
so
I'm erasing all my work.
you ever have that day where you feel really old?
Do you feel old right now?
I didn't know that the iPad did that
Let me
thing.
figure out why you would auto draw your circles and not.
Yeah, I do the circles, but I used to have trouble with the squares. It wouldn't do it.
No.
So we have the light. The first thing we're going to have is the gravitational force of the light, which is the weight. So we know its magnitude. So we have that. Going up. You have T3 holding the light. Okay, so
T3.
we do our sum of forces in the y direction. That's going to be T3. Plus the weight equals 0. But we know from positive y that it's going to be T3 minus the weight equals 0. So the magnitude is just 100 newtons. So the magnitude of T3 equals the magnitude of the weight equals 100 newtons. So in this, well, it's kind of hard to talk about let's just talk about magnitudes for now because T3 is going to be positive J hat this time. The next diagram is negative J hat. Remember, same tension throughout a single cable. Now, let's look at the other. So we found T3.
I had that one.
Okay.
Oh, that was a lot easier than I thought.
Now we have to find T1 and T2.
Halt.
I am going to introduce an idea from geometry. I'm going to move my angles. I just like the way it looks. Plus, you're going to need to learn geometry. You're going to end this year, like next semester, you're going to end this year with analytical geometry when we're doing optics. Well, light going through lenses, how does it bend? Where's it going to go? Light through mirrors, how does it going to reflect? Oh, geometry? It's an ancient form of mathematics that everyone hates.
Yeah.
I heard from he was like, he was like,
Teacher got sent to us.
So,
He can eat the rest of it.
what I'm gonna do is I'm gonna draw an X and Y axis, okay?
If he doesn't care about the bites
just don't.
taken out of it, let's just put it right there.
Just set it there and see if he says anything.
No, watch his face light up.
If he doesn't
Messing
care
with
that there's
someone's
bites.
food.
No, and
it's Piper's
Ethan,
food.
Ethan wants my sandwich, but if he doesn't care that there's bites out of it, he can have the rest of it.
That's really weird.
Oh, no.
So, I have an XY axis. I already know
I went to Catholic.
that I have, so I have T3 there, okay? It's gonna go straight down on the Y axis.
I think so.
So let's look at T1 and T2.
What a guy.
One, we go something like that.
Never got it.
Two, something like that.
Let's go Brandon here.
So. One, two. Now, if you look at the original picture, you see the cables hanging from the ceiling above, okay?
That's what
But
I
as
got
long as you
from
don't
that
care that there's
story.
bites out of it.
Now, if I think of this, if I think of my parallel there, I know that here I have phi, here I have theta, but I also now know that that angle is phi,
Wait,
and that angle is theta.
whoa. Oh.
Is it because of the elevation thing that we talked about in your office?
The what?
Like the elevation thing that we talked about?
No, this is,
Wrong.
Incorrect, never mind.
in geometry, there's a rule called alternate interior angles.
Oh, I remember that.
Alternate interior angles are equal.
I
So
remember.
you notice how the x-axis in the parallel, in the horizontal line that the
I used to be
are
so
hanging
good at
from
geometry.
are parallel to each
That
other.
was like 4 years ago.
So if I have a single line bisecting two parallel lines, the angles that alternate on the inside of those two parallel lines are equal.
You guys don't have to. We just gave it to you.
So-
I'll take it
6
back.
years ago. So what I'm gonna have now is I have to work on the components of these vectors.
It's not good. Maybe I can.
Basically, if you have an angle here,
We do our components everywhere.
you
Do
have
what?
another one here.
No.
We're rounding,
There's a-
we're rounding.
I don't think you should round in that case.
You tell Sonia that.
That is no bueno.
It'll still be the same. Pick at it.
Your ex is still
So
adjacent.
yeah, there's a piece of bit. Yeah, you can eat that. I ripped that out.
We
It
just-
looked great.
Okay, so now we have our x and y. So we're gonna work on these components.
Pesto mayo's fine.
Okay, so we're just gonna remind ourselves, T1x is gonna be T1 cosine of phi, T1y, T1 sine of phi. T2x is gonna be T2 cosine of theta. T2y, T2
That's the problem.
sine of theta. And now we have to start worrying about how are we gonna figure out what T1 and T2 are, because
Yeah,
we have
that's
two
right.
variables that we don't know. So like we talked about last time, we have a linear system of equations, so we need at least two equations to solve for the two unknowns. So what I'm gonna start with, sum of forces in x, that's gonna give me T1x
I hate my snap.
is 2T2x equals 0. And now I know, based on my positive and negative directions, so T1x is going to be negative plus T2x equals 0,
How do you know that they equal?
Yeah.
because it's a static system in equilibrium.
So it always equals zero.
Like when you end up in a system where you have where it's not an equilibrium, you have an acceleration, you don't have that here. The light's just hanging there.
What if it's swinging in the breeze?
We're
just assuming.
Trust me. Unless you're
Assume the
ready
easy
for a
way.
system of couple different equations, let's not have it blowing in the breeze. Let's just say it's
Okay with
hanging.
it being still.
Yeah. If we start adding in blowing in the breeze, you guys are gonna get to calculus 3 and differential equations real fast.
Oh, hell nah.
So,
Yeah, veto.
so we say T2x equals T1x. So this is the way I did it. I saw someone kind of do it the reverse way where they had T1 equals a number times T2, but let's go ahead and plug these in. So T2x is T2. Cosine of theta. T1x is T1. Cosine of phi. Now I know I'm going to need another equation and I'm going to need to substitute. Why? Okay. So the way I did it, you can solve for T1 if you wanted to. I solved for T2. This is going to give me T1
Hey, you know, I was at this point, but not really.
cosine of phi over cosine of theta. But I have theta and phi.
Wait, I think you.
So cosine of what? So 37 degrees over cosine of 53 degrees.
Yeah.
And what we end up getting is once you calculate those cosines and divide,
What's T1?
T2 is going to equal 1.331.
Oh.
So now we have something we can substitute into another equation.
Why you do
Well, this is assignment
Wait,
day.
go back up.
This is assignment day, so guess what? You're gonna do it.
And I'm gonna be in your office crying.
We go up a little bit more, just a little bit more.
I'm joking. I'm joking.
You're just gonna camp.
This is not what I did, but I'm still waiting to see what.
Wait, what's T1?
We haven't gotten there yet. We don't know yet.
How do you know T2 equals that?
Because if you look at the sum of forces in X, I can end up getting, I guess the microphone's in here sucks, so I should keep this with me.
I wish someone could see this.
But you notice how you did the sum of forces in X, and you had T1x plus T2x. Those are the only forces in X, those two components. So we know since negative is that way and positive is that way, T1x is negative, T2x is positive, so T2x is equaling T1x. So then I'm just gonna substitute in the expression for my components. I divide through by the cosine of theta, and since I know theta is phi, I can do cosine of phi divided by cosine of theta, and that's gonna give me 1.33. So we don't know T2 or T1 yet, but we know that T2 is now a multiple of T1.
So you get the 1.33 from the
Yes.
cosine, just
Yeah,
that
cosine
part?
37 divided by cosine.
Oh, okay, so you
So
don't,
that's your 1.33.
okay.
And so now we have T2, well, T2 is a multiple of T1.
So we have to time something.
Can I have the microphone?
I know, by someone, but
Nope.
It's so podcast.
I don't trust you after the first year of chemistry, and you don't have the microphones at work. Learn a lot of stuff.
Darn it. That was me.
So
I don't care.
now, the next thing we're gonna wanna do is look at our sum of forces in Y.
I don't even know what I should probably.
Okay, so what do we have in Y? We have T1Y, T2Y, T3,
It was the chaos class.
okay? So now let's think about positive and negative.
Bruh.
T1 and T2, they both point the same direction. So T1Y and T2Y, they both point the same direction. So they're both gonna be positive. Your T3 points down, it's gonna be negative.
You don't want me to.
Okay. Well, we can go ahead and move T3 over. Now let's substitute in the expressions for our components. Okay, so T1y is T1 sine of phi. T2y is T2 sine of theta. Then we get T3. Now, we have this. Let's put that in for T2.
Because he knows what he's doing. That's boring.
What did you say? He said, how does he write so fast? Like, because he knows what he's doing. Oh, you can't because you don't know what the hell you're writing.
Yeah, you ain't wrong.
All right, so let's substitute in. So we're gonna have T1 sine of phi plus 1.33 T1 sine of theta equals T3. Now the only variable in this equation is T1. It's the only thing we don't know.
Stupid team.
No. So I'm just gonna factor that out.
Would've just been there sooner. Just following the rules.
And when I solve for T1, that's what I get. And everything on that right-hand side now, I have numbers for.
What is that sign? What?
So sine of phi, sine of theta.
That's why I was writing theta for both, and that's why I was confused.
Okay. So that means T1. So what we have sine phi is 37 degrees. Theta 53 degrees, and T3 100 newtons. So when I solve for T1, T1 becomes 60.1 newtons. Now again, if you had gone the other way, where you solved and substituted in for T1, you would have gotten the same answer.
We did.
I was doing something, but I don't know what I was doing.
We just added a few more steps.
Times this. Yeah, yeah, so T2 is simple.
Immediately sub instead of going through.
Okay.
We did that.
Yeah, the first is.
You want to take off points for that.
So your T2 ends up equaling 79.9 newtons.
Yes, we did.
So, you wanna know where I went wrong?
Know where my head's at.
Sure.
Basketball against Thursday.
So, based on the picture that they gave me, I just assumed that the TY was equal to T1Y was equal to T2Y.
Nope,
Because the picture they gave me, it made it look like that.
different angles.
But when you draw a thing on it, it made it look like that.
Yeah,
I was copying what we did on the tight.
they have to be the same angle for them to be the same.
Oh.
So why didn't you tell me that last?
You might have-
My apologies, Miss Girl.
Judge Toller.
Okay,
It's a Friday. Okay. so
let's try to finish this chapter off.
you went-
So the last thing we're gonna look at is a system of pulleys. Okay,
Hey, I saw a pulley system would have been the gym.
did you?
I think that's what it is. Yeah, girl.
Yeah,
girls.
Is that for is that for like the one set of lifting you did between your hour-long texting session?
No, I don't even know where my phone is right now.
so excited.
I genuinely don't. Well, I can confirm she lifts. Yeah, Jada lifts with me.
So I'm gonna try and draw a pulley system. See how well it goes.
Gags. I am chronically online. This means I'm chronically online when I'm listening. Just take.
See, you're just looking to see what your next lift is.
Yeah, no. That plan's on. It's always just in my head. So. It's always just in my head.
And then he always has to do the budget. He's like, what do you mean chase his chick?
Okay.
Oh my gosh, there's literally one of these. In the gym.
Fun fact.
Okay, this looks stupid.
They would do one of them.
Have you finished the budget?
I'm not smart.
Yeah, that's what I could never do.
Okay.
Some eggs, right? But like.
So I have a system of pulleys here. I have two pulleys, and of course this one here.
They would do it with their drink. It was crazy. It must have been a cold thing.
I was cooking up.
Yeah, look at that.
But hey, I mean, whatever they did.
That's gonna be a mass hanging from the first pulley. Okay, so you see the two pulleys, you see the single cable going between the two pulleys, you see the second pulley being suspended from the ceiling, and then the first pulley has a mass hanging from it.
Just cough like an iPad.
I don't think this class today is real. I gotta go to work.
So we have our gravitational force.
I hear one more thing about biochem, I'm like, because I just got done with my anatomy, and I teach you how to break, but that's hilarious.
A pulley.
This is him showing us
It's,
what
look,
it is.
it's all in the word there.
Come on, Jana, get it together.
Okay, so
I literally know exactly.
He said he would have switched it to transportation. Yeah. Just crunching the numbers here.
That's just watching a good movie.
Where's
There you
tension
go.
B? Oh, there's tension B.
Okay.
and we have tensions A, B, and C.
A, B, C. C, D.
Nope,
I see a D.
Doesn't matter which letters they
Are those
get.
all C's?
No, okay, just
Wait,
making
why do you have
sure.
a D?
I don't have a D.
Oh, they're all C's.
Is A
One
in,
is a D.
I thought you
No,
said
it's
they
not.
weren't C's.
They're
I
all
thought you said they weren't even
Oh, you
C's.
wrote it wrong.
See, you're just trying to obfuscate because you don't know what's going on right now.
No, you're
Wait.
confusing me.
I have a question.
Yeah.
Why are the ones attached to A and the number or letter that I can't quite make out, why are those ones double arrows?
Ah, because if you look, so this is one of the things that usually drives people nuts about tensions. So from the point of view of the mass, tension A is pulling up. From the point of view of the pulley, tension A is pulling down. Two different reference frames. The pulley feels tension A pulling down, the mass feels tension A pulling up,
So that's why it goes. boop.
but it's the same tension.
So it cancels out.
Do you know that all the TCs?
Bomb-proof pony is
Yes,
great.
and why do I know that?
Because you're a physics teacher. Granted.
Yes, but there's a better reason than that,
Hey, yo.
because they're all the same cable.
Is the middle tension C, does that one have an arrow on the downside too?
Yeah, so,
There's tension C,
Yeah.
bro. Tension C.
so the arrow there,
Middle tension.
because this pulley, tension C is pulling up. This pulley, tension C is pulling down.
Okay.
I'm trying to get your attention and you weren't listening, so I just assumed it was Clash Royale.
What? It's the same room.
Okay,
Sneaking through.
Oh, so we want the total tension on the.
Pumpkin because a feet of all the blankets.
Okay.
Okay.
It goes, it's like a snake.
I see that, it's
So-
sneaky.
Yes,
we know that this
knew was
mass
good.
weighs 1804 newtons. Let's see. Draw the free body diagram for the system and show that the net force on this system is 0. So remember, only forces exerted by objects external to the system are included in the free body diagram. So let's go ahead and redraw our object.
Oh, just a square?
Yeah, just a square.
Wait, thought you were gonna make us redraw them. The whole polling system.
No.
Yeah,
So-
the circles are copied.
One thing we have
Yes.
She draws a box with that on the paper though.
is the gravitational force. Then on the very outside, you imagine on the very far right side, you have something holding the cable that's external to the system that's creating that tension C.
Same ever.
You have the ceiling on the very far left side holding the cable.
I had nothing else to do. Nothing else to do.
And then you have the cable in the center holding up the second pulley with the ceiling. So the ceiling is doing that one too. Okay,
So, okay, question.
Yeah.
Why is the one going down?
well, okay, so let's think about what's external to the system. The free body diagram that translates to the weight is from every force external. This tension C here is held by the ceiling. The ceiling is external to the system. There's something here holding the cable, keeping this steady. That's external to the system, so you get the tension C down. Here, you have the gravitational force pulling down. And then also external to the system is the ceiling holding up this pulley, so you have tension B. Everything in the center, so like your tension A, all that stuff, those are all internal to the system.
That makes sense, kind of, not really.
Internal.
Carson is just like.
So like between pulley and pulley, that's internal. Between weight and pulley, that's internal.
Now,
Because what you imagine, like your tension B and your external tension C's all translate into what actually affects the weight.
the two C's cancel out.
Want my other one?
You
Okay,
The one that has no bites out.
so now
Only your hand.
we have to prove that the sum of all these forces is 0.
Untouched.
Whether you just need like.
Okay, so we're gonna have to look at some multiple
It's not
free body
regular.
diagrams. I know, we won't get through it. But- So for the mass, we're just gonna do a simple free body diagram.
Trash cans over. But now I just get rid of adjustments. Trash cans. Okay, then.
So let's look at this real quick.
Where's the box?
You dimmed his light. I apologize. I was just joking.
Equilibrium system. Now, one of these, the tension A is pointing up, so it's gonna be positive. The gravitational force is pointing down. The tension A. equal Gravitational force. And so that's gonna equal 1,804 newtons. Okay, so next time we'll finish this problem up and get into the next chapter.
Can we revisit this problem in a whole on Monday?
Yeah, we'll talk about everything again.
Okay, yeah, that's,
I checked out.
I don't understand.
Yeah.
Wait, where'd you get that number? I didn't try to.
It says